In this video, we're going to learn how to write function reflections. By definition, a reflection is a transformation that flips a graph over a line called the line of reflection. And while any line can be a line of reflection, reflections are commonly done over the x-axis, which is this line here in red, and the y-axis, which is this line in green. And this type of transformation will not change the general size of this particular figure. All it will do is reflect it like you see in a mirror, like reflections in your mirror. So if you reflect something over the x-axis, or this line in red, here it would look a little something like this. So it's the same distance away from the x-axis. So notice those two bottom points are only 2 away. This upper point is at 7. And if we attach them all, that is that blue shape reflected over the x-axis. Over the y-axis, it would be similar, but the shape would be over this vertical line here. So notice again that all of the dots are the same distance away from the y-axis. They're just on the opposite side. So here we have our reflection over the y-axis. So before we start some examples, we're going to take a look at the formal book notes here, because these are actually going to be pretty helpful as we start to perform reflections algebraically. Now, I don't need you to write down everything here, but I do need you to write down a couple of key things for each of the different reflections. So the first reflection here is a reflection of the x-axis, and I would write this part down because you will need to know this terminology. A reflection of the x-axis is going over this horizontal line, and this is a vertical flip. So what I would definitely have written down here is that it's a reflection in the x-axis, and it's a vertical flip, and it's changing how we view that graph vertically. It's flipping it over in the up and down way. Then from here, the key parts in here are that you're multiplying all of the outputs or the entire function by a negative as you do this. So what we do is we're going to take that entire function, surround it in parentheses, and multiply the entire function by -1. Now I understand that might be confusing to you right in this moment, but what I would write down is reflection in the x-axis, vertical flip, and this key part here in red of y equals a negative f of x. Noticing that we're multiplying all of the outputs, or the entire function, by a -1. Then if we look at the second type of reflection here, we have a reflection in the y-axis. So I would write that part that I just boxed down. Now we're looking at reflections in the y-axis, and that's going to be this horizontal flip that happens across this green line. So I would, after reflections in the y-axis, write down horizontal flip. And what you're going to do here is you're going to take all of your input values, which are the x values, and multiply them by a -1. So notice here, we're multiplying our inputs. So outside outputs, inside inputs. So make sure you have those three pieces written down: the reflections, the type of flip that they are, and then the equation in red that goes along with them, as we'll be using that on the next few slides. So what we're going to do here is we're going to take all of the example functions from the previous lesson, and we're now going to apply reflections over the y-axis and the x-axis for these different functions. So here you can see we have a function f of x, and we're going to create a new function g of x, whose graph is reflected over the y-axis. So a graph that's reflected over the y-axis means that we're going to change the inputs, or change the x values, to have a negative x value here. Now, what's a little confusing here is we don't have parentheses in this problem. It's similar to that first example we did before. So I'm actually going to add those in here. So we have f of x is equal to 2. Remember, this was an x plus 0 because there's no h value. And then our k is on the outside. So we're going to change our input values, or our x values, to be negative. So here, if we take this example and we change that part circle in red to be negative, we have 2 parenthesis negative x, or negative 1x, plus 0 plus 1. Now you can rewrite this if you would like as g of x is equal to 2 with the negative x there as well. That would be fine. So I'm looking at noticing you understand that we're reflecting over the y-axis, and then being able to utilize the notes from the previous slide and note, well, I need to change the inputs, so I just put a negative symbol in front of that x. Now, for this particular example, we also have a function where we're going to reflect it over the x-axis, which is that vertical flip, and as a result, we're going to multiply all of the outputs by negative 1. So how this is going to look is we're going to take h of x is equal to, we're going to put a negative around this entire thing. So we're going to put negative, we have 2, and we have the x plus 0, and then we have the plus 1. So this is really complicated to look at, as I'm sure you're noticing. What we're going to do with this negative 1 is we're going to distribute it to each different group inside of here. So we're going to distribute it to the 2, and we're going to distribute it over to the 1. And we're not distributing it to this part here because this part is attached to the 2, so it's getting the negative 1 as a result there. So here we have h of x is equal to, we have negative 2, x plus 0, and then we have a negative 1 over here. So notice the slight differences here. If we have the y-axis, we're just adding a negative in front of the x. When we have a flip over the x-axis, so that vertical flip, we're adding that negative on the outside of the entire function and distributing it in to each group. All right, looking at example 3 here, this first one, we want to write something that has a reflection over the x-axis. Remember, the x-axis is a vertical flip and uses the equation y equals negative f of x. So we're multiplying all of those outputs by a negative 1. So here we're going to start with g of x, the name of our new function. We're going to have our regular function, which is x minus 8 plus 6 with that negative out in front. And what we're going to do is we're going to multiply that entire thing through by negative 1 because of this flip over the x-axis. So we're going to multiply through this first chunk here by negative 1. So that becomes negative 1 times negative 1, which is just a positive 1. So we have x minus 8 still in parentheses. Then we have a negative 1 times 6, which is a negative 6. So notice that I multiplied both little chunks. This is a chunk of the equation all being multiplied together. This is a chunk of the equation. Both little chunks get multiplied by negative 1. So here I have my new function, which is g of x is equal to x minus 8 in the absolute value minus 6. Now if we look at this next example here, we're writing a function h of x reflected over the y-axis, which is a horizontal flip, and is equal to y equals f of negative x. So that's because we're just changing the x value, the input values, to be multiplied by negative 1. So all we're going to do here is stick a negative 1 in front of x. So the rest of the function stays the same. And remember, if you don't like sticking that negative 1 in front of the x, you can also just write negative x, and that would work as well. So again, notice the slight differences. An x-axis flip, you multiply all of the outputs. A y-axis flip, you multiply just the x value, the inputs.